Alright, so now let us talk about thermodynamics. Okay, so try to observe what is happening here. So this is basically just a cup. Now inside this cup I've put water. Okay, so inside this cup there is water. So now what is happening is that the same water that I've put is trying to escape from this cup in the form of what? In the form of vapor. As we can see, it is just coming out by itself. Okay, I'm not the one who is conducting that vapor to come out from this cup, but it is happening what? Naturally. And we term that as what? Spontaneous. Okay, so this process that is happening here, that vapor coming out from that cup, we call that spontaneous process. So this process is happening spontaneously on its own. Okay, now as that vapor is moving from that cup to the environment, to the surroundings, it will leave this water inside this cup cool. Okay, so the water will be cooled in the process, meaning the heat that was contained by the water which was in the cup will be what? Will be released to the environment. Meaning here we're talking about what? Delta H, okay, which is the total enthalpy, the total heat energy. Now the total heat energy, since the heat energy is being released to the environment, the delta H here, or the total enthalpy, will be negative. Why? Because we're talking about what? Exothermic. Exo meaning exiting. We are exiting, the heat energy is exiting from the cup to the environment. Thermic part means heat. So we are talking about heat energy. Exothermic, exiting heat energy. Okay? So here we are talking about the heat exiting from the cup to the surroundings or to the environment. Okay? Now in the process, the water will be what? Will be cooled. Okay, as we can see, no one is even adding any energy here. No energy is being added, but it is just happening spontaneously, naturally. Meaning even delta G, Gibbs free energy, will be negative. Okay, so even in this case, delta G, which is Gibbs free energy, will also be what? Negative. So this explains the second law of what? Thermodynamics. So this is basically second law of thermodynamics, because we can see that there is actually disorderness of molecules. So water molecules are going everywhere to the surroundings, okay? They are going everywhere. So we term that entropy. Entropy. So this is basically disorderness. Okay, so this process that is happening here will continue in this state, and it is going to do what? To increase. So the disorderness will increase, okay, until the water cools. So that is basically the second law of thermodynamics. The entropy of a system which is happening naturally will increase. Okay, so this is now the same second law of thermodynamics. As we can see, it is also increasing the what? The entropy or the disorderness